यार के छ एकछिन कुर्नुपर्छ कि सुरु गर्दियौ हेलो सुरु गरौँ हैन तिमीहरुको 2:30 मा फेरि अर्को क्लास छ भने हैन
हो सर
ओके सो I guess we can start now, eh? So this is the point where we had left in the morning, and it was the theorem 2. We have completed these two theorems. Okay, so again, welcome back to you all in this afternoon session. Okay, so as we have completed the theory part of this, so let us start that exercise. It's exercise 24, I guess exercise 23, page number 328. Exercise 23, page 328. Question number 1. If R is equals to T square I minus Tj plus twice T plus 1K, find, there are several parts. I'm doing second one, dr by dt at T is equals to 0. So solution, given R equals to T square I minus Tj plus twice T plus 1K. Differentiating, you have to differentiate it. Differentiating with respect to T dr by dt is equals to I dt square with respect to dt component wise minus j dt by dt plus k d twice t plus 1 dt. So this turns to be simply I twice t minus j simply plus 2k at t is equals to 0, dr by dt at t is equals to 0 is equals to 0I minus j plus 2k. We are asked to find, therefore, magnitude of this dr by dt at t is equals to 0 is equals to square root of minus 1 square plus 2 square. This equals to root over 5. This is your answer. So nothing hard to understand. The next problem, 3/3. What is given? Let us see. For the curve x is equals to 3t, y is equals to 3t square, and z is equals to 2t cube. Prove that r double dot and then r triple dot scalar product is equals to 216. So let us solve this. The particle is moving on the curve, this, and velocity, this first order derivative is velocity. And remember that dr by dt is denoted by simply r dot भनेको है. अब second order derivative लाई double dot, third order derivative लाई fourth dot. We know rt equals to xti plus ytj plus ztk. So therefore r is equals to के भनेको त हाम्रो r is equals to xt is 3ti plus yt is 3t square j plus zt is 2t cube k. Therefore differentiating with respect to t successively, because you need up to third order, so differentiates this up to third order successively, you get dr by dt which is simply r dot, which is r dot, and this is 3i plus 6tj plus 6t square k. Again d2r dt square is equals to r double dot is equals to 0i plus 6j plus 12tk. And lastly r3 d3r by dt cube is equals to r triple dot is equals to 0i plus 0j plus 12k. Therefore r double dot, sorry, r single dot, r double dot, and then r triple dot, scalar triple product, r triple dot scalar product is equals to, as you have seen that this can be written in terms of determinant as 366 t square, and next is 0 6 12t, the last one is 0 0 12, and you can observe that this is the upper triangular matrix, so its determinant is simply is the product of the diagonal elements. 3 times 6 times 12 is equals to 18 into 12 is equals to 216, which is yes, so it is proved. के छ यसमा केही छ बुझ्नलाई गाह्रो भएको? ठीक छ?
ठीक छ सर.
ठीक है सर.
Okay. So next problem is, let me solve one from question number 4. It's third. What is said here? A particle moves along the curve x is equals to 4 cos t, y is equals to t square, z is equals to twice t. Find the velocity and acceleration. Find, first one is velocity and second one is acceleration at t is equals to 0 and pi by 2. So let us solve it. We know RT equals to XTI plus YTJ plus ztk, and this is equals to r. Therefore r is equals to, we have 4 cos ti plus t square j plus twice tk. So for the velocity you have to differentiate it. Differentiating with respect to t, you get dr by dt is equals to minus 4 sine t I plus 2tj plus 2k. Therefore velocity at t is equals to 0 के होने भयो dr by dt at t is equals to 0 is equals to sine 0 is 0 and just 2k, and velocity at t is equals to pi by 2 भने चाहिँ dr by dt at t is equals to pi by 2. This turns to be pi by 2 sine pi by 2 is 1 minus 4i plus 2 pi by 2j plus k, 2k. This is the velocity at t is equals to pi by 2. Again, for acceleration, differentiating dr by dt with respect to t, what we get is d2r by dt square is equals to d by dt of dr by dt. We have found dr by dt, okay, here it is minus 4 cos ti plus 2j plus 0k at t is equals to 0, d2r by dt square at t is equals to 0 is equals to minus 4i plus 2j, and at t is equals to pi by 2 d2r by dt square at t is equals to 0, sorry, pi by 2 is equals to twice j. Simply it is simply twice j, as cos pi by 2 is 0. So these are the velocity and acceleration. के छ यसमा हेर त? नदेऊ. ओके, सो यो पनि भयो. Next question is question number 6. Question number 6, what it says is a particle moves along a curve so that its position vector is given by r is equals to cos of omega ti plus sine of omega tj, अनि त्यसपछि omega is a constant, so that भन्छ, so that first ma velocity is perpendicular to r, and second भन्छ acceleration is directed towards proportional to acceleration is proportional to r and directed towards origin. Let us solve it. Given curve is r equals to cos of omega ti plus sine of omega tj. For velocity and acceleration, differentiating like differentiating one with respect to t differentiating one with respect to t dr velocity is equals to dr by dt is equals to omega cos को derivative minus sine omega ti plus omega cos omega t j. Therefore के हुने भयो, velocity चाहिँ perpendicular to भनेको छ dr by dt dot r is equals to कति आउँछ, यो 0 देखाउनु पर्छ हाम्रो. velocity is perpendicular to r भने that is dr by dt dot r is equals to 0 देखाउनु पर्यो. dr by dt भनेको चाहिँ minus omega sin omega ti plus omega cos of omega tj dot cos omega ti plus sin omega tj. This is equals to minus omega sin omega t. A dot b is equals to a1 b1 plus a2 b2 plus a3 b3 हुन्छ. के अरे स्पेस भेक्टर भयो भने, प्लेन भेक्टर भयो भने b1 b1 a2 b2. Omega sin omega t cos of omega t plus omega sin omega t cos of omega t, and these two being positive and negative, they cancel each other. Therefore velocity dot radius vector is equals to 0. So the velocity dr by dt is perpendicular to r. Velocity is perpendicular to r. velocity is perpendicular to r. Again for acceleration, differentiating dr by dt with respect to t, d2r by dt square is equals to minus omega square cos omega t. हेर यो dr by dt भने चाहिँ ओमेगा माइनस ओमेगा साइन ओमेगा टी छ, साइन ओमेगाको कस ओमेगा, ओमेगा चाहिँ चेन रुलबाट आयो, आई माइनस ओमेगा स्क्वायर साइन ओमेगा टी जे. If you take common minus omega square, then it is cos omega ti plus sin omega tj, which is r minus omega square r. Therefore, d2r by dt square is equals to minus omega square r. That is d2r by dt square is proportional to r, and omega negative sign shows that it is directed towards origin. This completes the solution. What? Okay, directed towards origin. के छ यसमा? बुझिया छ हैन कुराकानी?
Yes.
Okay. अब एउटा प्रब्लम क्वेशन नम्बर 9 के भन्छ भने if r is a unit vector, then prove that r cross dr by dt को magnitude is simply dr by dt को magnitude हुन्छ भन्छ यसले. नमस्ते, म एकैछिन क्लासमा छु, एकछिन फोन गर्छु है हजुरलाई. We have r is a unit vector भनेको छ है, r is a unit vector. We know पहिले r को a क्रस b भनेको चाहिँ के रहेछ, r क्रस dr by dt भने के रहेछ भन्ने थाहा छ हामीलाई. म्याग्निट्युड अफ r, म्याग्निट्युड अफ dr by dt अनि cos थीटा सरी sin थीटा क्रस प्रोडक्ट भएपछि sin थीटा आयो, sin थीटा n क्याप हुन्छ. Therefore यसको म्याग्निट्युड ल्याउँ भने r क्रस dr by dt magnitude is equals to r को त 1 हुने भयो, युनिट भेक्टर भनेको छ हामीलाई. त्यसैले dr by dt sin थीटा अनि यसको पनि म्याग्निट्युड भयो n क्याप. n क्याप पनि फेरि के हुन्छ, 1 हुन्छ. यो युनिट सर्फेस नर्मल हो, युनिट सर्फेस नर्मल भएपछि यसको म्याग्निट्युड पनि 1 भयो, यो पनि 1 हुने भयो. त्यसो भएपछि फाइनल्ली therefore r क्रस dr by dt magnitude is equals to, sorry यता म्याग्निट्युड छुटेछ, dr by dt sin theta. Now you know you need to find the angle theta. Angle theta is angle between r and dr by dt. So angle theta find out गरेर यहाँ ल्याएर राख्न सक्नु पर्यो. Since r is unit vector, so it has constant magnitude. So it has constant magnitude 1 constant unit vector को magnitude त 1 हुन्छ. So by constant magnitude theorem के हुन्छ याद छ r dot dr by dt is equals to 0 भनेर चाहिँ ओ theorem 1 बिहान पढाएको थियौ नि हामीले constant magnitude theorem ले a dot dA by dt is equals to 0 भनेको थियो नि constant magnitude theorem ले त्यही लगाएको हामीले. अब त्यसो भए therefore or magnitude of r magnitude of dr by dt अनि cos theta is equals to 0 भयो. And r magnitude, this r magnitude, since r को magnitude is not equals to 0 unit भनेको छ अनि dr by dt को magnitude पनि not equals to 0 मैले क्लेम गरे. Therefore cos theta is equals to 0 is equals to cos of pi by 2, that is theta is equals to pi by 2. यहाँनिरको यो dr by dt r not equals to 0 त युनिट भयो. dr by dt not equals to 0 किन होला के होला रिजन भन त
नत्र क्वेशन नै मिनिङलेस हुन्छ.
गुड यो क्वेशनको बोथ साइड नै के छ भने dr by dt आइरा छ के बोथ साइडमा dr by dt छ. अब dr by dt यदि 0 हुने हो भने त यो 0 इक्वल्स टु 0 को त कुनै मिनिङ भएन. त्यसैले यो चाहिँ यस्तो आको है. ल थ्यांक यू. Therefore using theta is equals to pi by 2 in 1 भनेर लगेर राख्यो भने r cross dr by dt को म्याग्निट्युड भनेर चाहिँ त्यहाँ के छ dr by dt को म्याग्निट्युड अनि sin थीटा छ यो भने sin pi by 2 dr by dt magnitude sin pi by 2. Therefore r cross dr by dt is equals to magnitude of dr by dt proved भयो. So with this problem solve गरेर 9 नम्बर सम्म यसको एक्सरसाइज को गर्न सकिन्छ. अब भेक्टर को इंटीग्रेशन को सानो कुराहरु
सर
भन न
सर यो हाम्रो के रे पार्शियल चाहिँ गर्नु पर्ने छ पर्दैन
पर्छ पार्शियल पर्छ हैन. त्यो खासै केही छैन. पार्शियल भनेर त थाहा छ होला नि तिमीलाई. त्यो x र y को आयो भने x को रेस्पेक्टमा गर्ने बेला y लाई कन्स्ट्यान्ट राख्ने पार्शियल डेरिभेटिभमा पढाएको छौ नि त्यही हो.
ए हजुर हजुर.
अर्डिनरी कुरा मतलब अर्डिनरी भन्नाले जनरल कुरा नै हो. पार्शियलमा नयाँ कुरा केही छैन. अब यसमा हामीले थाहा छ हामीलाई यो रिकल गर्दै भने मैले तिमीलाई के रे डेरिभेटिभ अफ fx dx इज इक्वल्स टु अथवा क्यापिटल fx भन्दियौ सम्झ्या छौ भने डेरिभेटिभ अफ fx dx इज इक्वल्स टु स्मल fx भयो भने इंटीग्रेशन अफ स्मल fx dx इज इक्वल्स टु fx प्लस c हुन्छ भनेर पढाएको छ हामीले हैन. अनि त्यसपछि अर्को के पनि पढाएको छौ भने इंटीग्रेशन फ्रम a टु b fx dx भनेर चाहिँ fb माइनस fa हुन्छ भनेर पनि पढ्यौ. इंटीग्रेशन यो माथिको इंटीग्रल fx हो भने त्यही कुरा नै हामीले यहाँ रेप्लिकेट गर्न खोजिरहेका छौं है. के भन्छ भने यसमा चाहिँ इंटीग्रेशन अफ भेक्टर फंक्शन अफ स्केलर भेरिएबलमा चाहिँ हामीले ख्याल गर्नुपर्ने के हो भने if derivative of rt vector with respect to t is equals to small rt dt हो भने then integration of rt dt is equals to capital RT plus some constant vector C हुन्छ है। अनि त्यसपछि अर्को चाहिँ if RT is equals to XTI plus YTJ plus ZTK छ भने then integration from T1 to T2 RT dt छ भने I integration from T1 to T2 XT dt plus J from T1 to T2 YT dt डेरिभेटिभ जस्तै प्लस के कम्पोनेन्ट वाइज गर्ने T1 to T2 ZT dt हुन्छ। यो दुईटा कन्सेप्ट थाहा भयो भने you can handle the problems from the integration of vector function of scalar variable है। It is exercise 24 and this is not so hard to do. Let me do few of them for you. Question number 1 को exercise 24. Question number 1 को first मै के भन्छ भने 1 to 2 2t square I plus tj minus 3t square k यो चाहिँ हाम्रो अनि dt छ। As just mentioned के लेख्न पर्यो यसलाई this is equals to I बाहिर आउने भयो 1 to 2 2i नै बाहिर आयो t square dt plus j 1 to 2 t dt plus minus 3k minus 3k 1 to 2 t square dt. Nothing new here. Twice I t3 over 3 1 to 2 plus j t2 2 1 to 2 plus sorry minus 3k t3 by 3 1 to 2. This 3 and 3 cancels. This is equals to 2 by 3 I 8 minus 1 plus j by 2 4 minus 1 minus k 8 minus 1 है भने this is equals to 2 by 3 2 पनि नबनाओस् यसलाई एकैपटक सिम्प्लिफाई गरिदिउँ। This is 14 by 3i plus 3 by 2j minus 7k. This is your answer. त्यस्तो खासै केही छैन। ओके एउटा डिफरेन्शियल इक्वेसन सल्भ गरौँ। इन्टिग्रेसन भने चाहिँ डिफरेन्शियल इक्वेसन सल्भ गर्नै काम लाग्ने हो। लेट अस सल्भ द डिफरेन्शियल इक्वेसन के छ भने 3 को सेकेन्डमा d2r by dt square is equals to eti plus e twice tj and given that dr by dt is equals to I plus j and r is equals to 0 at for both t is equals to 0 है। बोथ को लागि t इक्वल्स टु 0. Solution. We have d2r by dt square eti plus e twice tj, or d by dt of dr by dt, very fundamental principle for solving differential equation, eti plus e twice tj, or d by d of dr by dt is equals to eti dt plus et I लाई अगाडि राख्दिउँ न, I et dt plus j e twice t dt. So in order to remove the differential dx भनेर राख्यो भने अनि यो र यो त हटेर जान्छ, यो डिफरेन्शियल हटाउनलाई यसलाई x आउँछ, त्यही हो हाम्रो. हजुर के भन्नु भन त?
के पनि छ हैन? के
त्यहाँ छ र छैन? यति नै त्यहाँ छ.
प्लस के पनि छ.
ए प्लस के रहेछ? हो, थ्यांक यू. ल ओके, प्लस के प्लस के प्लस के प्लस के प्लस के dt भयो. थ्यांक यू. इंटीग्रेटिंग अब इंटीग्रेशन गर्नु पर्यो डिफरेन्शियल हटाउनलाई. integrating both sides, if you integrate both sides, then you get integration d dr by dt is equals to I integration et dt plus j integration e twice t dt plus k integration dt, or dr by dt is equals to I integration of et is et plus j integration of e twice t is e twice t by 2, and then plus k t plus some constant c अथवा c1 भनौं. गिवन के छ हामीलाई? गिवन dr by dt is equals to I plus j for t is equals to 0. Therefore, dr by dt at t is equals to 0 is equals to कति हुने भयो? I plus j by 2 मात्रै भयो, प्लस 0k भयो, यो चाहिँ प्लस c1 भयो, or it is I plus j is equals to I plus j over 2 plus c1 vector. Therefore, c1 भनेको कति आयो? j by 2. Therefore, like 2 भनौं, from 2 you get dr by dt is equals to what you get? I et plus j by 2 e twice t plus kt plus j by 2 मात्रै भयो जस्तो छ है. or dr is equals to, again integrating भन्दै पनि भइहाल्यो, बुझिहाल्छ होला. यसलाई धेरै कति लामो लेख्दिने हैन. again integrating again integrating, if you integrate, integration of dr is equals to I integration of et dt plus j by 2 integration of e twice t dt plus k integration of t dt plus j by 2 dt integration. सकिन्छ होला यसलाई हैन कति हुने भयो r is equals to I et plus j by 2 e twice t by फेरि 2 आयो plus k t square by 2 आयो plus j by 2 t आयो plus c2 भयो अनि गिवन के छ हाम्रो गिवन r is equals to 0 when t is equals to 0 त्यसो भयो भने त 0 is equals to I plus j by 4 अनि अरु त 0 भइहाल्यो प्लस c2 भयो अनि यो c2 को भ्यालु लगेर राख्दियौ substituting value of c2 गर्दियौ we get the required result है get के हुने भयो r is equals to I et plus j by 2 e twice t j by 4 आयो j by 4 plus k t square by 2 plus j by 2 t plus sorry minus हुने भयो अब यहाँ minus I minus j by 4 अब यसलाई simplify गर which is required result. So this completes again this exercise on integration है अब हामीले फंडामेंटल इंटीग्रल अथवा नर्मल सरी फंडामेंटल अर्डिनरी क्याल्कुलस चाहिँ सक्यौं अब एडभान्स क्याल्कुलस छ फंक्शन अफ वेक्टर फंक्शन अफ स्केलर भेरिएबल को एन्ड देन बल्ल 3D मा गइन्छ अझै दुईटा क्लास लाग्ला यसलाई भेक्टरलाई है आज यति गरौँ अब ओके सो यति नै गरौँ मेरो क्लास छ अर्को है र यो टार्गेट थियो यति भए पुगिहाल्यो आजलाई अब सन्डे चाहिँ दुईटा पिरियड गरौँला है शेयर Okay, let us stop here. Thank you.